Okay, so Railer has a question from 17.1, which is basically, sometimes they ask for counterclockwise stuff, and sometimes they ask for clockwise stuff, and how in the hell am I supposed to make it one way or the other, right? So the thing you want to start with is this idea. Whenever they say something about a circle, right, you should think to yourself, polar. Right? It's like, circle, polar, duh. Okay, so when you think polar, that causes you to think x is r cosine theta and y is r sine theta, right? So if they tell me to draw a circle of some radius, so for example, I think number, what is it, 21, says draw a circle of radius 1 in xy plane counterclockwise. Okay, so I saw the word circle, I thought polar. Polar looks like x is r cosine theta and y is r sine theta. What's the radius?
1.
Radius is supposed to be 1, so I'm going to drop the r's, right? Pretty cool. Okay, thetas.
Just theta is too high. It's not.
I don't know. What the hell am I? What does the theta do in polars? What is that thing?
Just one. Like.
Yeah, that's this thing, right? That's the thing that's driving this motion.
It's multiple of the period.
Yeah, so that's kind of the percentage of the way around the circle you've gone, right? Where 0 is 0% and 2 pi is 100%.
If you want the period to equal 2 pi, then the coefficient of theta is equal to 1.
Yeah, we could fiddle with the thetas, right, to make this go faster or slower, right? Why did I just say faster or slower when I'm talking about an angle?
Because it's all with respect to time.
Yeah, because I'm just kind of thinking like, well, what the hell? Theta, time, same thing. Theta's like a Greek t, right? That's not actually true. The Greek t is tau, but whatever. Right? The word starts with t.
So what letter would theta be?
So I'd probably, and it doesn't actually matter at all. So you could do, let me see, I'm supposed to parameterize a circle. So I'm going to call that thing c of theta. And that should get a vector hat, right? It should be a parametric curve. So what's your x component, what's your y component, and did they tell me this was in 3 dimensions? My textbook is restarted.
This is in XY plane, so it's 2 dimensional.
They said in the xy plane. Well, the xy plane lives in R3 though, right?
Oh.
I'm just going to toss it in there to be safe. Z is going to be 0, right? That's going to get me in the xy plane? Okay, now is what's my x coordinate supposed to be?
I think the answer was 2
Well, because the radius in the problem is 2.
Oh crap, the radius in the problem is 2. So you can't just drop the r's, you need to put 2 in for the r's. Okay. And then, oh, they said clockwise in the problem? Okay, good. Okay, so now that we've actually got the problem written up there, I'm just going to think to myself, well, x is 2 cosine theta, right? Like this is a first shot, am I not? And y is?
Negative sine, negative 2 sine.
What? Nah, y is 2 sine theta, right?
That's not.
Like, don't be ridiculous. Okay, now I need to check which way I'm going, right? So, when I think about this, it's all pegged at z is 0 anyway, right? So when I plug in theta is 0, where does this thing start?
1, 0. 1, 0, 0.
How about 2, comma 0, 0?
Oh, right.
Okay. And then, when I change that angle theta, which way does polar go when you change the angle? Oh, crap. It goes counterclockwise, right? If it goes that way. I want it to go the other way. So, to get it to go the other way, what do you do?
Change the sign on the sign.
No, don't be ridiculous. I mean, that's the effect. But What you want to do is you want it to go backwards, right? So don't be silly, just run time backwards. So stuff a minus theta in there for both of those. And then notice that you can rewrite that, because cosine's even, right? As 2 cosine theta, comma, negative 2 sine theta, comma 0. Goes all with that?
Okay.
So the fact that I'm running time backwards is this thing that's getting me to go in the right direction. You guys cool with that? Now, what if I wanted to start it somewhere else?
You would.
You mean by start somewhere else, like start.
Like, what if they told me to start on the y-axis?
Would it be like
Then x would equal
negative
sine.
2 sine? Just switch the x and y's basically.
Yeah, you like swap the x and y's, right? Really, what you're getting away with here, right, is exploiting the Pythagorean identity. You guys see that? Like, the reason I know I'm on the circle is that I know that 2 cosine theta squared plus 2 sine theta squared is 2 squared. Right? I'm just exploiting the Pythagorean identity. I'm saying, hey, I know this is a circle because, hey, it satisfies the equation of a circle, right? You guys cool with that? That actually is not enough. That's enough to know it's part of a circle. You guys see that? There's a good trig reason, right? Well, like, we could run all the way back through the trig and figure out that this is, in fact, all of a circle. Where are your theta's range now?
Still be 0 to 2 pi though, right?
Yeah, you need 0 to 2 pi here. Or at least 0 to 2 pi will start on the x-axis, right? So if I say theta is in 0 to 2 pi, this will start on the x-axis and go once around with my adjusted time. It'll go backwards, right? You guys all good with that? What if I only wanted the right half?
It would be negative pi to pi.
Yeah, you'd want to run from negative pi to pi. In this one, you'd be running that backwards, though, so that would get you the left half.
I noticed they gave the range for t, it included 0, but it didn't include 2 pi. That's so you don't double count it, right?
Yeah, you could include 2 pi and not 0 if you really wanted to. You guys see that? Like, totally equivalent would be to not include 0, but include 2 pi. You guys good with that? I don't really care whether you double count that or not. It's not going to matter in here. As long as you know that it's getting double counted, that's fine. You guys cool? Questions, deals on that? So basically, start with polar and then adjust, and that'll get you this clockwise counterclockwise thing. Otherwise, you can try plugging in a couple of points and seeing, or you can like take your function, take the derivative, look at where the derivative's pointing. You guys see that? Like in here, if you took the derivative and evaluated at theta equals 0, on ours you'd get a vector pointed this way. On the one we tried at first, you'd get a vector pointed that way. Good? Cool? Questions?